Right. Oh no, okay, so it seems that more people are watching. Oh no. Okay, so basically I'm back on my PC again. Hopefully I'll actually be able to stream reliably on my PC. But I couldn't be bothered to wrangle with the config files to get 2 screens working. So all I can see is this, which is currently like the super cool Inception stuff. I can do cool things with it. But yeah, basically I've got chat on my phone, which and one of the groups I'm in is being quite hyperactive right now. No connection. Okay. Can I just... Yeah, okay. Phone's on silent. Right. Okay, I will just try my hardest not to be distracted. In fact, I could... I'll lean the phone against... I don't know. Lean my phone against this. I have no idea if the viewer numbers... Okay, the viewer numbers is completely inaccurate, it seems. Okay. Right, anyway. Let's just get rid of this. Okay. So, what I'm thinking of doing today is basically keeping on going what I was trying to do last time, but got hopelessly distracted, as I often do, because I'm superbly distractible. And that's to try and parse something from a grammar, right? Like, not because I particularly think this is the way Sapling should be run, or like that this implementation is the way that should end up in Sapling. What I'm more concerned about is just, just get a feel of what it's like to specify a grammar for an arbitrary language and attempt to parse it, basically. Or like generate a parser. Because Sapling's needs are a bit specific. There isn't really anything that's like it that exists so far. Hold on, am I massively behind? Okay. Oh, come on, phone. Don't be silly. Rotate! Dratted phone. Oh, here we go. Okay, right. Okay, well, hold on. If people could just spam stuff in chat so that I know how much delay I've got on my phone. So if just like you all say hi or something, I don't know, then at least I can see. Because I think it's quite high, and my phone was playing back the video from a couple of seconds before you guys were seeing it. So I was like, all right, okay, that's fine. That does help. Yeah, that seems fine. Okay, so basically, let's get started. So pretty much, the idea of using a grammar rather than parsing a language is that currently, yeah, I said this last stream, but basically, oh, great, that's cool. Currently, Sapling uses a specific parser for every language, right? And that's fine for now, but it's fundamentally unsustainable in terms of how many dependencies Sapling needs. So it would be a lot better to have some way of describing a language and then feeding that description into Sapling, and then it can say, oh yeah, let's just parse something knowing what I expect the language to look like, and here's some stuff, parse it into a syntax tree, right? Which is slightly more general than just, oh yeah, I have a hard-coded knowledge of the language and I take some text and turn it into a syntax tree. So, what have we got? Okay, you know what? I think I'm going to do this in a a different directory. Make and change directory. What should we call it? Parsing tests. Cargo init. And we want a binary. And then let's move this. So now both terminals are pointing to the same place. Excellent. So let's also cd into source, even though I only expect to use one file really. So pretty much now we have to like decide two things for this like test. I don't want to have to interface with the rest of Sapling because that's really complicated. And we need to decide how should a syntax tree be stored and how should the grammar be stored. And as far as like parsing is concerned, I think recursive descent, generating a recursive descent parser is probably the easier option. And it's more general and all those good things. So I think for the time being, we should have trait AST, which currently doesn't have anything in it. And let's create a new, let's create an enum. And the point of trait AST is not the same as the AST in Sapling. Because, yeah, okay, so, yeah, and let's have a struct node, and this has a type, or, ooh, and type is an AST, and then we have children, and this is vec node. Right, yeah, we need to implement this A, and this is vec node A. Right, so yeah, so the children of a node of a certain tree. So this is basically like a language. In fact, we could probably no, I kind of think this is better. So this would be the equivalent of AST class currently. If we go sapling source, actually we do want to then some source AST JSON. I think it's probably the easiest. So, oh, and it's generated by a macro. That's kind of annoying. But basically, this is a super simple macro. Macro? No, it's an enum that describes the possible types of an AST node, or the classes, right? So you could have strings, if statements, like whatever. That would be, these would be language specific, and they would describe the possible things in a language. So we would have something like, what do we need? Oh no, yeah, let's keep going, and then let's create a new enum, which is for the language JSON, right? And this should implement AST eventually. And this will have stuff like true, false, null, array, object, field. And notice how these don't specify what their children are. Like, this is not field JSON, which wouldn't compile anyway, but we ignore these, which I think this is probably not the best strategy for long term, but I think for the experiment, we may as well experiment with one more thing, right? Is my thinking. So JSON, let's just derive a load of useful things. Derive copy, clone, debug. What else? Well, oh yeah, we want eq, partial eq, hash. And then, yeah, let's make it AST stuff. I probably should have done this before stream, but you know, like this is kind of bashing out some boilerplate stuff. Incredibly good code here. Very constructed, right? Fair. So enum JSON. No, we need to import AST for JSON, which currently doesn't need anything. Yes. So one of the first things we need to do for every language, right, is we need to be able to know what kind of trees are valid, as opposed to just like letting everything go, because all we've got here, we could name this class instead. There's no kind of the node class because we're not checking things in the compiler. The node struct has no inherent checks on what's valid. So like, I don't know, having true and then as a child of true an object, like that's clearly completely useless. Like no way would you ever expect this to work as JSON, but that is completely representable. Like you could just make let equals node, and then you could be like class JSON true, and then children, and that's a vec, and I mean, yeah, children has one child node, right, and we can say class object. I mean, like, literally anything here is wrong, and then children is vec. This is happy. Why is this not happy? Okay, so this is completely constructible, and I'm kind of tempted to allow invalid states like this to be constructible, because temporarily, like, you should never be able to display this to the user because it can't be, but temporarily I think it might be useful to be able to do this. Like when you're replacing children of nodes, it might be worth doing this. Let's just call this invalid, since it is. So what we first need is something that's like, is the tree valid, right? Or are children valid? And this takes reference self and then children. We probably actually ought to only give this impl iterator over item is pointers to self, I think. And then we need to spit out a bool to say whether or not this is fine. Okay, well, right, so if we bound this with copy, then it's fine, we can take all these out. And it's complaining. Okay, so obviously we're going to have to match over this, and then match. Oh yeah, match self, because we need to do a different thing for each type, right? So JSON true, JSON null. Yeah, JSON false as well. Also should not have anything. So for all of these, we just automatically return false. Or, yeah, we return children.next.is none, basically is what we want to return here. Oh, that's a compiler error. Yeah, we want these to be pipes. Yeah, new Also, I think we should pass around references, because we will want some way of representing strings. And I think if we're able to just like pass strings along too, then that's better. So this is self. Right. Okay. Well, the compiler seems to be more hung up over this. How on earth do I make sure that this is valid? Huh. Do I have to say where self is an A? Oh, this is confusing. If someone who actually knows what's going on here could help. Oh, right, no, okay, nice. So what have we got now? Oh yeah, so JSON string also should have no children regardless. Missing array, so JSON array. So now all we're asserting an array, the only thing you can't have as a child is you can't have any fields. So children.all C is not JSON field. And we need yeah, okay, so object, like ideally this whole thing should be generated by the grammar as well, right? And then for objects we assert the opposite, right? Like every child of an object has to be a field, and lastly for field, which I think is the only one left, we need to assert that children dot. We can do some like very hacky stuff. So children dot next is some, yeah, so this needs to be some string. Oh no, okay, right. I think we need to do this with if lets. Is some, how would we do this? So basically what I'm trying to look at, what I'm trying to say is that like the left child needs to be a JSON string. Yeah, I think we just have to do it with like if let. Oh my god, what's Rust format doing? Is children.next. So yeah, left child has to be these. And then if that's true, if the first one is some string, we make sure that the next one yeah, so we need the next one to be not a string. Map or yeah, so I think we need so we need to default to false. So if there isn't an X child, then we return false, and otherwise we have some child, and then we assert that C is not equal to JSON field. Right, so this should be a bool. Oh, shouldn't field be part of the object type? Well, so it depends, because if we're allowed to put like vec of children in here, right? Like what we'd ideally say is something like this is some vec of pairs of strings of JSONs, right? This would be like the compile time safety thing. But the thing is, we're trying to avoid specifying the children in here, in the JSON type, right? So each language shouldn't be able to specify, like, what am I trying to say? So the language types themselves shouldn't encode what the children are. The children should be added on by node here. And that this should be fine. We should be able to do this if the language in question is context free, then that should be okay. So what's going on here? If I let x bool. Okay, right. Oh yeah, so we do need else false. And this is, yeah, so we need to pop a value and then assert that this is actually the only children. Like this is quite janky, I think, but this should at least be fine. And then we can say down here that invalid dot are children valid. Oh, this dot class dot are children valid. Okay, right. So we need a thing in here that's like. Oh, in fact, this is thinking about this. This is like a bit orthogonal. I just want. Yeah. And we're actually not. We're going on a track. Fun is valid. Cool. And then we want to say. So we first want to check whether this node is valid, so that's like self.children dot is dot are children valid. Oh no, self.class are children valid, and then we pass in self.children dot map dot iter map x, and then we. Oh, good. Yeah, so like the point of this is not to like, yeah. I've just seen chat. Okay, so x dot class. Right, I think this should be fine because this is import iterator. Do we have to borrow here? Oh, that's fine. It's happy. But we also need to check that all of the children all node dot is valid. Right. So we just like this is essentially a like recursive call down to the children to say like, okay, well, in order for a tree to be valid, like the root has to be valid in it, like locally valid, and then all of the children has to be valid locally, and all of the children of that. So we just like bubble down the tree. And now if we cargo run, oops. Actually, this should probably be a test, but whatever. Invalid is valid, right? And we expect this to be false because, yeah, because the tree is invalid, because we gave true a child. Good. Let's turn this into a test. Mod test. Apologies for the formatting, but Rust font is amazing. Kind of annoys me slightly that Rust doesn't import everything from a parent module. Oh, does that shut it up? Oh, okay. Oops. I keep switching between like desktops rather than Windows, which is why this is happening. Okay, test. Oh yeah, and this should be assert. Assert bang. Assert that it's not valid. Okay, and we could write more testing cases, but this is kind of orthogonal to the point of actually parsing anything. Yeah, I will construct these. So basically now we need to kind of represent this as, like, we need to be able to parse something. And I'm not quite sure of the best way of doing this, because we want to, we need some kind of general grammar. And the general grammar for JSON, if we're looking at it from like a context-free grammar, is we have some kind of value which turns into either true or false. So here quotes are, yeah, I might as well explain how CFGs work. So here we've got variables which are like things that could be expanded into something else. So imagine we're like, instead of parsing something, we have a specification and we want to generate some phrase or some text in that language. And in this case, we actually won't be generating text, we'll be generating a stream of tokens, which is tantamount to kind of pieces of the language, right? So, for example, like the word enum is a token, this is a token, this bracket is a token, and then here's, this is a token, and the comma is its own token, right? So like, these are all chunks of the language. But importantly, white space between them doesn't matter. So if I do this, then this is still valid. It doesn't matter that there's a huge amount of white space in between. I mean, it's obviously not good, but it's valid. So a JSON value can be true, it can be false, or it can be null. I'm just going to forget strings because they're a bit weird. Or it can be an object. Well, how can it be an object? Or let's say take an array first. So an array is opens and closes with a square brackets, and this then let's just kind of like make some stuff up. So we have so we start with an open bracket, right, and then we have some arbitrary value, right, and then comma, then an arbitrary value. So we kind of like alternate value, comma, value, comma, value, comma. And I'm assuming that star works the same way as how Rust does, as it does in Rust macros. So we're allowed, star in this case forces us to end on a value, and then we finish up with a closed bracket. And it's quite cool. We can like we can see that already we can represent any like arbitrary nesting of arrays, right? Because let's say we had the like this JSON, we had true, false, false, true in an array. Well, how would we generate it from this grammar? Well, the only variable we have is value. So we're just kind of assuming, like in order for this to be valid JSON, our tree of things we expand has to start with value, right? So we take value and then we expand it to, well, what do we expand? Well, the outside is an array, isn't it? So we have to expand this section, and we have to start off with an open bracket, because that's the thing we started. And we wouldn't know this if we were actually parsing, but we know that we're going to have 3 values, right? And then we're going to have to close with a closing bracket. In fact, we could, to be consistent, we could start off with like these and say, oh yeah, well, so the commas are, the things in quotes are final pieces of text that will concatenate together at the end. And then here we can expand the left one. This value here, well, this is another array, so we can expand this again into value, comma, value. And then we have the same commas from before, right? Because we've essentially taken this string and then we're replacing the value in here with something else. So we start off with the opening and closing brackets and its value here. And then we can like keep doing this, right? We can keep expanding. This value, oh, well, we need to end up with true, so we just use the rule up here that value goes to true as a literal. So we just go here. And we can see like our expansion here has stopped, right? We've expanded value and there's no, we're just ending up with strings at this point. So there's no way to expand again. We just do this and then we expand this value here, this value into false. And then we keep going. No, this is getting really hard to read with all the quotes. So we may as well just like concatenate all these strings together, right? So we have all of this as the first thing. And now we have a value to expand. Well, that value is false, so we expand it into false. And like I'm sure you can like get the idea at this point. You can see where this is going. That we'll expand false here. The last value will expand into another array, so it has a opening and closing, and it has only one value inside it. So on, we expand this value into true, and then we just concatenate. And because we allow white space between tokens, it doesn't matter that like this is completely identical to the one we had before. We can put spaces in here. And this is the thing that we wanted. And this is quite cool, actually. Like, when I learned about it, I was like, oh, this is really nice, because this is, from this one line of specification here, we now know, like, this rule essentially is an encoding of every possible bit of JSON that's only arrays, right? Like, I think that's really cool. And we have something, like, okay, so this is not fully JSON, right? You need, we need to have some way of encoding objects as well. So we could have like, oh, well, objects start and end with curly braces. And then from the way I've just written the grammar down here, if we're trying to end up with this, then we have to do field star, and their fields are separated, right? So, well, what's a field? We just like created a thing here. Well, a field, we need a new rule for field because we don't actually know what to do with them yet. And then a field is some kind of string which we're just going to pretend we know what to do with so now. And then it's a colon, and then it's some value. And this is kind of, this is quite powerful. Like this is, at this point, if we have strings, so we just have a last rule that's like, string is, well, it's magic, as far as we're concerned, okay? And at this point, like, we've completely described JSON. This is completely how JSON is described. And if we could somehow parse this, then we've done it, right? Like, this is all Sapling should need to take, and this should be able to figure out, oh, okay, that's a simplification. We need a bit more information. We need to know, we need stuff like this bracket here, what token type is it? For syntax highlighting, right? We need to know, well, what's a constant, what's just a piece of punctuation that should be white. So we can do proper syntax highlighting, like where as a keyword, and so on. And this is like, this kind of seems oversimple, right? Because JSON is fundamentally a really simple language. That's why I started with it when that's why Sapling is the only thing that Sapling can parse at the moment. But it's also, it kind of has all of the pieces of the puzzle that a lot of bigger languages have, or more complicated languages. It has a variety of things that you could have. So you have like the value data type, which has lots and lots of different options. And you also have recursion, because we have value inside here. So we can have values inside values, if you like, which is the same for like, you know, expressions. So for Rust, we'd have something like expression could be an expression plus another expression. That could be one way of doing things. And then we'd have more. We'd have like expression times expression, and so on. What are the other operators? Minus, so on. Expression could just be a const, or something like that. Like it could be true. And what else have we got? Oh, but we've got negative. We've got unary minus for like minus 4 times 3. We need to parse that separately. So we've got this, and then like it's sort of obvious that everything, like that nearly all languages can be represented like this. And the reason why is because, like, it's really hard to write a compiler for a language that whose grammar doesn't form, like this, if the specification doesn't have a round form, or like a neat way of representing the specification for a language, it's really difficult to verify that your compiler is correct, or whatever's going to end up parsing the language, right? Because even in Python, you have to have some kind of specification, and by far the easiest way of making a specification is writing a context-free grammar. So essentially, what the job of parsing at this point boils down to, right, is that it's the task of taking, so parsing from 10,000 feet, 100,000 feet even, is we take a grammar plus some string, right? So we have, we say, here's a grammar for a language, here's a string, which we hope is an example of the language. And because we're making a projectional text editor, we require that this always returns an AST, or at least I would like to require that it always returns an AST. Because obviously you could do something dumb, right? You could have, even in JSON, you could have just like a closing bracket, and like, what is that? Like, that doesn't parse, that doesn't mean anything. So we'd quite like some way to say, we parse this, and then we go, well, actually, this is actually an error. It's some kind of thing that we can't understand, but we know what type it is. The type is value. because we know this is all the text we've got, and our specification, like our grammar, has said, oh yeah, well, the entire string has to be a value in its entirety. And so we know it's a value, and the error is a closing bracket. So I'd quite like this to go through our parser and, or let's say parse JSON, right? And then we want to turn this into an error of type value, and yeah, we could be cheeky and give this names string. And also, like, this gives us a lot of information about how to, if we're only specifying stuff as grammars, let's ignore the fact that this might not even be possible, right? Some languages might just magically defeat all of our grammars. But let's pretend that you can, in fact, specify every language as a grammar unambiguously. Then the input to Sapling, like the bit that the user sees, is they write a specification for their language. Maybe you go to Tree Sitter and get one that someone else has written, but you write the specification for a language, and that's it. You give it to Sapling, and you open a file of that type, and Sapling handles the rest. And that's the holy grail. Like, okay, it's not quite the holy grail. Like, something that magically figures out what language you've got would be ideal. But this way, the user has no idea about how Sapling is working internally. Like, this is completely implementation independent, right? We don't have to know, we don't have to figure out, oh yeah, well, JSON Sapling is internally storing these in an arena allocator, so we need to make sure about that. Like, no, you just give a grammar and you give some text. So you give Sapling the grammar for the language, and then you open a file and it works. It just parses it into the syntax tree. Like, obviously, this grammar itself is not enough for Sapling to open it. We need to know more. Like, we need to know what, like, this, let's say we wanted to create one of these. Like, we wanted to create a true, like, what character should this be? And stuff like that, right? We need extra rules for that. But fundamentally, it should just be a grammar, in my opinion. Like, does that kind of make sense? And also, does my super fast lesson on kind of like how long is it? Like, it's a very fast breakdown of how context-free grammars work. There's a lot of very cool, like, theoretical guarantees about them that I won't get into, largely because I've kind of forgotten. But yeah. So now is the question of, like, I'll just wait for a bit for the stream, for chat to come through. Oh, also, yeah, so how is this, like, text size as well? Would it be, like, useful to have it a bit bigger? Because we can make it a little bit bigger and fix, like, 100 characters. Create 100 hash. Whoa, that's perfect. I remember learning it at uni as well. Like, this whole, we had a module, I think it was called Models of Computation that this was in. We did, like, regular expressions, what are they called? DFAs and NFAs, context-free grammars. Yeah, it's so good. It's like, it's kind of the cool middle ground between, like, it's really theoretically cool because you've got, like, I mean, yeah. I hope I did it justice. But it's like, yeah, I mean, it's not it's not something that if you're not doing computer science. Yeah, I mean, that's the same, right? Like models of computation, theory of computation, same kind of thing. But it's just like really cool because you've got all like this theory stuff, and it's like, oh yeah, well, what's a regular language and what's context free and all of this stuff, and you're like, oh well, this is cool and all, but like, is it actually used in practice? And yes, it is, right? Like these things are everywhere, and obviously like Turing machines are kind of the benchmark of computation and all of that stuff, and it's like, I really loved that. But then I got to the exam and it was, that exam was unbelievably hard. Yeah, that exam was ridiculous. But like, you know, can't deny that it's very cool. A very cool topic. So what we'd actually like, having just written all of this code. Yes, that's like, that's one of the things I was thinking about. So, like, I was wondering how... Yeah, physics has other cool things, though. I mean, like, the stuff you learn in physics is always going to hit the, like, if the stuff you're learning is cool, which, you know, not everything is. I don't want to shit on bits of computer science that I don't like. But, like, all of the stuff in physics is fundamentally, like, you're trying to describe the world, right? Whereas the stuff in computer science, like, no one would say that context-free grammars is trying to describe the world. Although, actually, fun fact, they were originally invented, like, they didn't come from computer science, or at least context-free grammars didn't. They came from linguistics because, what's his name? What is his name? Noel Chomsky, that's it. Was trying to describe, he was trying to find a way to formally describe human languages, and then arrived at context-free grammars as like a way of doing it, and basically discovered that human languages are way too complicated, and then you just like can't. Well, it was basically his conclusion. It was like, hey, this is very cool, and on paper it's fine, because you could have like, it looks really nice because you can have like sentence, and then a sentence is like, I don't know, you can have like the cat, like cat pushes dog or something. You could have like noun, verb, noun, but that's like not the only sentence structure. You could have like, you could have something that's like, okay, well, you have to have, what are these things called? Like the or and, I don't know, like, what are they even called? I'll call it the and thing. So like the, yeah, and then we could have like the and. Except that, like, obviously this is used twice, so we may as well split this out into a thing that's like, hey, we have, like, big noun, if you like, right? And then that's this, basically. And then this is, like, big noun. So it's like, the cat, I don't know, chases the dog, would be expanded from this. But the issue basically was that articles, yes, excellent, that's what they're called. So it's like article noun, except that you could put a load of adjectives as well. So you can have, and in fact you don't even need this. You don't need an article. So it's like, oh, well, maybe we have an article, and I don't know. We also have some number of verbs. So we're like, no, sorry, adjectives. So we have adjectives, and then this is some number of them, like any number, like 0 or more, right? And then article is, well, it's either. And we can use, say, article like turns into a concrete thing, like it's either the or a or an. Alright, this should be this, right? And like this is kind of cool, right? Because you can kind of see that you might be able to describe English like this. But the issue is that because it's made by humans for human consumption and was never like designed with this kind of thing in mind, There are just like horrendous edge cases all over the place. Because like the sentence "no" is grammatically correct within context, and then it's just like, you know, like the whole thing becomes a mess because humans are involved. But for programming languages are just for they're designed for computers to consume. So they obviously have a very fixed form. How would we do this? Does this look better? No, it doesn't. So yeah, where was I before I rambled about this? Oh yes, I was answering the thing. So would you be better off creating a parser macro that describes these rules in Rust of the above text? That's one way of doing it, and I think that tools like that are usually called parser generators, right? Because they yeah. Okay. So English is perhaps one of the easier languages. Like French also has the whole like some adjectives happen before and after the nouns. I've never have I been to Slovakia? I think I might have been, but I have no idea how Slovak works. Yeah, it's probably quite fairly alien to English speakers. I did learn German actually, and German. I've got to give German that it's a very, very well-defined language as human languages go, right? Like, clearly, it kind of says something about German culture that, like, or like the German mindset. I don't know. I don't want to be too. I don't want to just like sweepingly stereotype here, but like. Oh yeah, like English is a crappy language. Exceptions are just bad. Like even in programming languages, I don't think they're a good idea. But yeah, okay, French is perhaps not a good comparison because I think French also has tons and tons of exceptions. German is very, very good at like having rules and following them. But also it has like 7 words for the, which I don't particularly like, to be honest. Well, okay, so yeah, so German being very, very logical is all very well, but I think you miss out. You miss out on like the playfulness of English. I'm not sure. Oh, that's interesting about Indian languages. Yeah, so yeah. German has horrible bits. Like I think if you took genders out of German, right? Like so, like having to assign a gender to everything out of German, it would become a much better language because of it. I honestly don't. I wouldn't really begrudge having lots of different words for the different cases, or not cases. What are they called? Conjugations? No, like the different contexts for like. Oh yeah, well if you like your something is being relative to the something. I'm not openly like I'm not sure what would happen, right, if you had like different words for the in different contexts. Like I kind of like the way English has one, and I think it makes English relatively easy to pick up to a level where you can communicate with someone, right? It's one of those relatively easy to be okay at, but really, really hard to actually, like, it's relatively easy to communicate with someone in such a way that they get your message but know that you're not native English speaker, basically. Okay, so the I don't have nothing. That depends where in England you are. That sometimes means, like, I think in parts of London, that's very well, I think Cockney that has, that I don't have nothing is like that's completely okay. But that's just a dialect thing, basically. And also most people would understand, like English speakers, like specifically British people, talk very, like you need a lot of context. Yeah, okay, so dialects are a separate issue. But like I remember, so we had a like, I used to live in the US, right, when I was young, and so my parents have like friends from the US, and before like the whole COVID thing happened, we used to have a fair few people. Like occasionally we'd have American guests around, and I remember like one time we were cooking, and my mum like is really good at cooking, so she was cooking, and the American friend was like hanging around and chatting and helping, you know how it goes, and my mum was like, yeah, we were just like frying something. What? So, what's this about Slovak? I'll read the thing about Slovak later. So yeah, pretty much. My mum was. We were trying to fry something, and then my mum was like, "Oh yeah, put a drop of oil into the pan, right?" Because a drop in English, you're just like, in Britain, like a drop means, "Oh yeah, some," right? Whereas our American friend was like, just like put a drop of oil in the pan. But like, yeah, British English is in particular is very like playful is one way of putting it, and like wrong is the other way of putting it, right? But it means that stuff like cryptic crosswords are just like not a possibility in German, right? Because there's nothing cryptic about the language. Cryptic crosswords are cool, actually. I might, I'll just like for the people who aren't, yeah, for the people who aren't. Wait, so what that makes really good sense? Like what? Is that the bit about like an empty set is defined as a set that doesn't contain nothing? That's, yeah, I don't know. That's very broken. Like, can I find a good? A good cryptic crossword clue to describe how they work. Yeah, I mean, like it's really annoying for like someone, you know, for like someone learning a language. The playfulness is super annoying, but it allows for very cool things like cryptic crosswords, which I'm trying to. Oh yeah, easy cryptic crossword clues. Can I just get like a clue, please? Yeah, well, like pretty much like talking to particularly British people, like particularly British English, is very. Yeah, you basically have to. You have to make it very. You use a lot of context when talking. Right, so like. Oh, okay, right. So here we go. So. Oh wait, of the other crossword. Oh, okay, yeah, but yeah, that makes sense. But this clue, for example, like, yeah, I mean, like, I couldn't do that in enough, like, time pressure. But basically, so this like depressed in Widow Nightmare, right? Like the clue, and it's 4 letters, and the clues in cryptic crosswords, like the idea is that the clue means one thing, but inside like the clue is hidden instructions to build up. Like the clue is not a literal clue, right? So like depressed in Widow Nightmare, like 4 letters, that doesn't make sense as a sentence, but it does actually, like, hidden inside it are the way the way to build it, right? So the way it works, like this is definitely an aside, but it's cool nonetheless. So you have depressed, you have a definition on one end, right? And then the rest of the clue tells you how to like build the word. So for example, depressed is the definition in this clue. The answer's down for 1. So depressed is, if you're depressed, then you're down. So that's the meaning. And then down is hidden in, so depressed is in Widow Nightmare, right? Because down, Widow Nightmare, right? So like, that's the kind of thing I like about like it being playful, because the only reason you can do this a lot of the time is because English has tons and tons of edge cases and exceptions. What's the star light up Rebel City? Oh, so this is this is celebrity, because celebrity is a star, and lit up is like an anagram, and then Rebel City is the anagram fodder. So celebrity is an anagram of Rebel City. So like, yeah, they're kind of cool. What's this? Former wine contains exhaust. I don't know. Anyway, that's enough of an aside about English being chaotic. I'm also not like hugely into cryptic crosswords. It's just my parents are, and I know a couple of people who are. Cryptic crosswords are like, they're very, very British specifically. American crosswords are very different. And it's kind of like, yeah, it's a sign of the way British people speak English, is that cryptic crosswords are even possible. Yeah. Hold on, where was I? I feel like I've massively digressed from what I was talking about. Where were we at? Oh yeah, it was about like building, using proc macros to build the stuff, to turn a grammar into the code for parsing it. And that's like one way of doing it. That's probably the way, if Sapling had a fixed set of languages to support, that would be the way I would implement this kind of thing. Because it's nice. Like you turn a specification into some code, and then the code can be compiled by the Rust compiler into super fast machine code. And then you can like statically link it all together. The thing I'm worried about is that that's not particularly, like, how do I say this? That's not particularly runtime extensible, right? You could do plugin stuff. But what I kind of like is that, like, Sapling internally, so you could have, like, Sapling from 10,000 feet. So Sapling is essentially, like, it's some kind of list of grammars. And it's, like, it internally has a list of grammars, and it picks the right one. What am I trying to say? Oh yeah, so basically what I'm thinking the right way is right now. Like, I'm not saying that's the be-all and end-all way, right? But the first thing I would try and do is to make Sapling parse at runtime the grammars, right? So it takes a grammar, it has some fixed code that takes a grammar and an input string and parses it. And that means that you can have, like, grammars would just be, they would just be files on the file system somewhere. And you could have like what I would like is some kind of centralized, like kind of like cargo for Rust and like Pacman, all of the other package managers, right? There's some kind of central repository of grammars that's curated by like the people who make Sapling, right? Not necessarily me, but that's like a trusted source of grammars. And you could like obviously install a different grammar if you want. But what I quite like is that, let's say you are opening Sapling, and Sapling maybe installs with a load of grammars that you might be useful for, like, I don't know, the top 40 most popular file formats, right? I don't know, something like that. And then if you were to try and open another file format, let's say it would be like open some C file, right? And Sapling goes, oh, I don't know how to do this. Then it would just like ask the central repository for, can I have a grammar for C? And then the central repository would go, yeah, here it is, sends it, and then Sapling parses the grammar format in whatever, like, however that works. Maybe it sends an executable, or it sends the string of the grammar, or it sends, I don't know, like the grammar in a more easily digestible format for a computer. I don't know, it sends it in JSON or whatever. Like, anyway, that's unimportant. Basically, like, there should be some central repository for grammars, and if Sapling opens something that isn't that, then it goes and just fetches a new grammar. And that should happen within maybe like half a second. So you don't even notice that you've got it. And then we can keep grammars up to date as well, because languages change. And if languages change, then the grammars have to as well, if the syntax of a language changes over time. So yeah, pretty much what I'd quite like is to be able to, like, ideally I'd like to do this at runtime, which I know is not like, it's not the Rusty way of doing things. Like, the whole point of Rust is that you do less at runtime. You do as much in the compiler as possible. But yeah, you know, I think the worst problem, I think safety will not be much of an issue. I'm not super worried about that, because it's not like you're providing loads of untrusted input to your parser generator, right? The worst the parser generator does is just like says your entire file's an error. Like, that's kind of the worst you can do. And the grammars will most likely be specified by us anyway. So I'm not super worried about safety of the parse of like doing all of this grammar stuff at runtime. But like, it is very flexible, right? Because you can be editing the grammar, and then in real time, like, Sapling could reparse the file or something. That would be cool. If you're developing the grammars, it would be really, really handy to have this kind of thing. But yeah, I'm not really sure. This is something that's pretty gnarly, and I don't think, like, Tree Sitters attempted this. And that's basically the only time anything like this has ever been attempted, right? Like, trying to make a formal grammar that can capture every language and then write a generic parser generator for it. So it hasn't really been done before. I quite like the challenge of doing stuff that had never been done before. But no, yeah, it's quite hard. I'm pretty sure that whatever we do, like, the first thing that we try will not be the best. But that's okay, right? Like, that's like, code never works the first time, like, nearly never. But yeah, so also with a bit of luck, I'm kind of hoping that next year, so at Oxford we do, in the computer science department, we have like 2 undergrad projects. There's one in 3rd year, which I'm doing right now, that's like unrelated to Sapling and stuff. And then there's one next year as well, which is like, it's a very big project, so I would be able to put a lot of time into it. And I'm currently if I can find a supervisor who will be happy to supervise Sapling as a project, and you like ignore the fact that it's open source and that I've started it already, then that would be ideal in my opinion, right? Because I would be able to throw lots and lots of time at it. But also there are other projects I'd quite like to do. This is very me. I have lots of ideas and flit around them, and then a few of them stick. Like, to be honest, it's mostly like the only reason I haven't given up on Sapling as a project is because of the amount of like support it's got from other people. So yeah, just like thanks to everyone who like, you know, watches these streams even, especially the people watching the stream, who watch the streams, and like all of the people who've starred Sapling as well and forked it, you know, watched it on GitHub. Again, it all makes a difference to how much, like how much I believe in the project. It kind of sounds, I don't know how cliche that sounds, but yeah, it's true. Yeah, let's try and make a runtime parser generator, right? Because yeah, this is going to be spicy, but let's try it anyway. Like, if people have questions, like or anything, just stick them in chat, and I should see them. I think, yeah. Chat is scrolled down to the bottom. That's okay. So, what should we have? Like, we need some kind of struct that's struct grammar, and how well? What even is a grammar? Well, it has a load of rules, and well, what's a rule? I'm not even. Well, so basically, we're trying to represent this. Okay, well, like we can leave strings as essentially magic for the time being, and just not have to parse them. But we need a way of saying something like this: that we have value on the left-hand side, and that value. We can't create values explicitly, right? You can't like go to a JSON syntax tree. Like if I go to this, no, and then oh, what's going on? Yeah, here we go. Come on, compile. Yeah, right, so if we're editing some JSON, right, like there's no way we could insert a value, right? Because, well, what's a value? You can't insert it, but we kind of need it. We need it as a type so that we can, again, it needs to have a rule, so that we can, you know, we can parse it. So what's a rule? Well, terminal. How do we? This is super gnarly. Like, because basically for every one of these, because basically the things we give key bindings to are actually that they're the transformations, right? Because you could like these bars here. These are essentially like they're kind of syntax sugar. For we have one transformation that's value to true, then value to false, and value to null. That's essentially what these bars are saying. And what we could say is that, well, this is called like the right hand side of this rule is called true. So on the left hand side, I think we need to, let's just type, we need non-terminal is string for the time being, right? And these are also called variables, so let's call them var. And then, well, we need to have some way of representing a terminal, which is like when we've like they're the things here where we end up with something in quotes, which is like the kind of end of the line of expansion. And terminals will in fact be tokens as well. So let's call it TOC, even though like this is kind of the specification of a token, I guess, because it's part of our grammar. And well, what have we got? Well, it has some text, right? What's the text? Well, that's a string. And it also has some kind of syntax highlighting annotation, right? That's like highlight col. Or it's like, what category is this? Even. And for the time being, let's just make this, let's make a new type. In Sapling, we already have a syntax category type. But for the time being, let's just make it usize. And then highlight is syntax category. And then, so, right, so a rule has left-hand side, it has to be a variable, right? Because the rule is this represents left-hand side goes to right-hand side. And we can also have a, we need some kind of enum for like a mixture of variables, var TOC, which is like either a variable, I'm not sure whether this is good coding practice or not. But anyway, we have, all right, the right-hand side, which is the thing that we expand to, which is some vector of var TOCs, right? Because we could have a thing that simply expands into its, like, yeah, we could have something that expands entirely into tokens, like the transformation value goes into true. And then we also need to assign this a character. And then in our like notation, then this is like this. And so now I think we should be able to write this entire grammar here in terms of like this specification, apart from strings, which we're going to like assume is magic as far as we're concerned. Oh yeah, and this is n for null. Yeah, maybe we should have something better than like just mapping straight to characters, but we can fix that later. And this is an object. Okay, I'm on the warpath to get a new keyboard. This has no string. Like we can't. Oh yeah, so strings are essentially S in here. Value goes straight to string. And this also has no. Yeah, like this is just assumed to be magic. Like you can't. The figuring out what's a string and what isn't is like just left as basically magic. Right, so what have we got here? Well, in our main thing, main, let's move it up a bit. Yeah, above AST stuff, because I think AST is, like, we're not going to use that directly. Let me see, so let JSON grammar equals, right, so what is it? Well, oh yeah, we can get rid of this as well and put it in AST stuff. And now we can see our entire definition in one go. So we need to turn, oh, this is way too far away. Let's turn this into its own comment and grab it so that we know what we're doing. Right, so this is a grammar, and the rules are, well, vec. So now we're trying to like describe, we're trying to convert all of the individual rules here into some kind of, yeah, we were trying to convert them into our custom data type, right? So we have rule, yo, hello, sup. Oh, have you just arrived? Are you the new arrival? Hello, welcome. Welcome to the pizza party, as they say. Yeah, basically, if you're new, I'm building a text editor. Okay, so it's not a text editor. It's a code editor where you edit the code and you kind of try to avoid touching text as much as possible. In fact, I can do a demo. Have you seen... yeah. Have you, like, seen a demo of Sapling or not yet? Because I'm happy to do one. That would be an excellent distraction. No, it's fine. That's kind of what streaming is for, right? Like, it's for because like programming stuff on stream is not like it's never going to be particularly efficient because I can program better on my own when I don't have to talk about what I'm doing. But what stream is really good at is like people can ask me stuff and I can like run my ideas past chat and stuff. It's basically like more open than just me coding and then making pull requests in my own repository and everyone else just like trying to watch. Okay, anyway, so what's the first rule? The first rule is, in fact, let's maybe make a constructor for this. Impl rule new. Yeah, this is going to be like the world's most verbose format the world's ever seen. Like the specification of this grammar is not going to be succinct in any kind of a way. This rule, but this is not the point, right? Like the point of this is that this kind of like giant data collection of data types is going to be would be how Sapling would internally represent these if we do it this way. And if we do it, they go down the whole proc macro route, then we'd still need to do this. Like, we still need to have an understanding of what a grammar is. And then we would use this, like, super verbose format to generate a parser. Or in the, like, doing the parsing at runtime stage, we would parse our grammar into this data format, however that works. And then we would use this to directly parse a string or a token string. Same kind of difference. Like, it doesn't really matter if you parse streams of tokens or just text. They're kind of the same because you can tokenize pretty easily, or lex is sometimes what people call it, lexing and parsing. I'm not going to get into the discussion of whether or not what's lexing and what's parsing. So rule new, and well, the left hand side is a value. I'm kind of regretting this, I think. Yeah, I think I should probably have some kind of data type for this. But for the time being, right, we've got string, and this has got to be to string. Actually, okay, I'm going to be really happy here, and instead of string, I'm going to have add static str. This is purely so that this becomes easier. Right, so value is now correct, supplied one argument, that's okay. Well, this conversion has a char. Oh, in fact, that's a point. Conversions might not have a... they might not have a character, so this is sum t, and the result is vartok token, and for the time being I'm going to make this yeah, okay, so let's, for the time being, ignore syntax categories for the time being. Talk equals this. Hello. Tuple variant defined here. Oh yeah, right. It's complaining about this. And then this is some token, and the token is true. Bruh. Oh, veg. Yeah. Oh, I forgot to update it up here. Hey, oh, nice, okay. Oh yeah, this is not gonna work. Fun times, like, let's just copy, oh yeah, clone debug. Now I need to do that for all of these. Wrong thing. This. And then everyone, yeah, right. So, oh, print is not a function, duh. And then we go back to parsing tests. Okay, well, yeah, we've got a functioning rule now. I mean, we haven't tried parsing anything yet. Let's have another rule. Well, this is also taking a value, and then it's going to be false. Value null. I'm going to just pretend that strings don't exist for the time being. So we're going to skip string and then go straight to an array. So we're on this line now. Array. And this is a bit more interesting because we've got token, and then we've got another value, and then vartok token closing bracket. Right, and I think we just delete this. We don't. Oh, no. Why can't Vim just leave my screen where it is? Okay, and okay. So I'm also going to pretend that that objects don't exist as well, because in fact, how hard is that? Like for parsing, that's not too bad, because we just have more rules. We have a rule that's basically this: it's value through O. Oh wait, hang on. This is not even correct, because we need an arbitrary number of these. These turns into fields. how do we do this? Well, so the way you do this in context-free grammars is that you'd have you'd create a new thing that's like values, and then value is either a single value or it's a values, then a comma, then a value, right? So you do this as like linked. This is basically cons lists because it's either yeah, this is the same as lists in Haskell or Rust. It's like well, a list A is it's either just singleton A or what is it, nil. Okay, this is almost the same. Is it even? No, so it's either nothing, which in itself, right, nothing needs to be a valid input string. It's either nothing or it's, oh my god, this is even more annoying than I remember, right, because this is either nothing or values, comma. How do we do this without? Yeah, so okay, so we need and we need another thing again, right? Because we need to say we're basically trying to represent this data structure, right? Like a grammar for it's some number of values alternating with commas. You know, like this being according to like Rust's macro syntax. So we need things or nothing or values, and then now values is either a singleton value or it's value, comma, values, right? And one of them will be faster, like the left recursion or the right recursion are basically equivalent as far as Sapling is concerned. One of them will be easier to generate than the other. I can't remember which way around it is. There's like more, yeah, there's like, what am I saying? Because of the way parser generators are implemented, something like this will be faster. And this is equivalent to saying a list of A is either it's either nothing or it's a cons of A onto another list. In the like Haskell, like pseudo Haskell, I guess. Except that I want to avoid this because also this creates a very deep tree because it has like all of these things that gets like all of these substitutions have to happen, and then the tree ends up like really deep and left recursive, and that's a pain because now like the children don't line up because ideally you'd have like an array and then an array has tons and tons of children, right? Also an array has any number of children. But instead you end up with like an array has one child, which maybe has like the thing in the array, or it has a thing. Like it doesn't make sense because oh yeah, let's do an example. So like true, false, null, right, or array. We want this to become array with as children true, false, null, and another array, right? All so that all these four things are direct children of this. But if we did it as this like crazy context-free grammar thing, in fact not crazy, like context-free grammars are useful, but not for us. Then it would have an array, well it's an array and the child of the array is values or nothing. And then inside that it turns into values because there's more than one. And then the first one, well, I don't even know how to describe it. This is, it's like cons, whatever this rule over here is called. Because the things you'd have to do is you'd parse the entire thing and then you say, oh, well, how do we represent these things inside it? Well, it's values, and then as a left child you have like value, and then it goes to true. Maybe we could skip this step, right? So it's values true. And then the right-hand child of this is more values because we've got false, and then values then we've got null, and then values. Like, you can see how mad this is getting, as far as sapling is concerned, right? And then this is an array, but even better, right? Like, it's okay. So yeah, we should do this instead, and then this is an array, and then an array has to have something inside it, so it's values or nothing, and then it goes into nothing. And this is absolutely not the way we want sapling to see stuff. We want it like this. So I think we need some kind of construct that's basically alternating between two things. So instead of vec vartok, I think we need like a right-hand side thing, or rule right-hand side, and so yeah, so it's either a var or a token, or it's like repeat, which is some kind of rule, and in fact we could even limit it to like oh, I'm getting confused. It looks like other people are too. Right. Well, we need some kind of way of representing repeat. Right, so this is becoming rule right-hand side. And then the left-hand side is a rule, but we can't do that. We need to box it. Otherwise Rust will complain. And then, well, it's repeat, and let's just make it a token. That's the delimiter, right? This is rule right-hand side. Okay, I know. Let's create a new thing. Oh no, let's just use find and replace. There we go. Well, I think I might just. Hey, what? Oh, I think I can't help but think that the find and replace is broken, which is really sad. Or the rename thing is broken. So in fact, we need. Oh yes, you don't need box. That's a good point. Yeah, nice, because we got indirection already, and now instead of this, then we can have. Oh yeah, we should probably rule right-hand side, because we don't want to, like, they don't want to be entire rules. So instead of this, we need a repeat, right? We need a and it's repeat, and we're only repeating one thing. It's this var alternated with rule right-hand side token toke comma does that parse? Oh yeah, okay, so we don't even need to specify that it's a token terminal. Yeah, okay, and then this is, yeah, let's just recreate this again. And through O we get this, and then, I mean, it's the same except that we're alternating fields. And now we finished the rules for values, like all the way that a JSON values can get converted, and now I need fields. Field goes through none because you can't actually create fields. And then the left-hand side is a str, which we're not going to define, it's just going to be like magic. And, oh yeah, so we need vex, some number of rule tokens. Well, right-hand side dot var string. I'm just going to pretend we can parse those, and it's, oh, what we also need is rule, right, yeah, so it's string colon and then rule right hand side var, it's just any value. Like, does this kind of make some semblance of sense? I think it probably does. Like, it's a horribly verbose way of describing it, but it does. Also, I need a pee. I should probably just like go and have a pee, and then I'll actually be able to concentrate. Right, pee break. I'll be back in a minute. Also, mute. Right, be back in 30 seconds. Okay, right, we commence. Where are we? Okay. So what was I doing? Oh yeah, so we've defined a grammar in terms of strings, and now we need to parse. Like, we basically, so I think this compiles, right? We just brain engage. Yeah, so we need to basically turn this like this grammar here into we need to parse it. Like, we need to use it to parse something, and I think it would probably be easier to feed it already tokenized data. So let's create tokens, and this is just simply going to be a stream of tokens. So what was our example? It was yeah, we had an example up here that was like an example string. It was this one, right? So we're trying to do this. yeah, so this is the thing we're trying to parse, and the tokens are this, comma. And then we need a closing bracket. I think these are, yeah, they are, okay. So all the brackets match up, that's okay. Oh, in fact, we've forgotten some commas. This is like the worst way of looking at like tokens, but there we go. Let's just check print lum, and then we just print tokens dot iter. Join the empty string. It's not graph. Rust analyzer, what are we doing? How do I just like concatenate a load of strings together, right? I just want to, like without doing something stupid like folding. Okay, let's consult Google. Oh no, that's not what I... iterative strings. Clearly I'm not the first. Ooh, iter tools. Do we really have to... it's the slice directly dot join. Right, thanks. Oh, yes, wonderful. Oh yeah, that looks like JSON to me. Cool, right, so we have some tokens and we need to parse that given some rules. So actually the grammar is not quite complete. We need to tell it what the starting rule is. And that's like the variable that we start with when, like, yeah, this is kind of like the type of the entire file, if you like. So in this case, it's start var is value, because the root type will be value. Like I know also the lack of static typing here with all the strings, like it causes me pain as well, if that's if that's any consolation. Might not be, but anyway. So what have we got? Right. Well, we have tokens. Yeah, so we basically need to be able to parse something. So we need to have like impl grammar. We need to have a parse method. Parse, and it takes self, and it takes a slice of tokens, which I think are defined as static strings. But anyway, yeah, so we take a string of tokens and this, oops. So we're assuming the tokens are already inputted. And, well, so what do we return? That's the question. And I think we need to return a tree. But here's the question, how do we represent trees? Let's comment this all out, I think, because it's just giving us compiler errors. Oh, I do love it when, just like one of the small things that's nice about Rust, that a lot of modern languages do, and it's not just Rust, is that you can nest comments inside another comment. And this is just something that really bugs me about C, is that if you had like this, then it would, like, the parser would like be going through and it would read this and then it would go, haha, everything else until I see this is a comment, which is really dumb because it means that it would stop here. It would match this one to this one and then not do everything else. So I'd have to like figure out a way around this. But Rust is like, oh yeah, well, this is the start. Then this is clearly, like as soon as we see a second one, we need to see more in order to... Anyway, that's an aside. Niceties of someone else's parsing. And now we need to return something, and for the time being, we'll just return nothing. But we need to have a node struct node, and well, node is, what does it have? Well, it has a type. Yeah, and it's like, what variable does this correspond to? And this will be used for checks. Oh, whoops, this is a var, I think. And it also needs to know what its children are. And that's vec. Oops. I can't wait to have a proper keyboard. Yeah, so then, and in this case we need to output a node. Because obviously, this should probably be... oops. Dang, right, so now the question is, like, how do we even parse stuff? Because it's all very well... oh, in fact, we're unlikely to even have tokens as a vec. Oh well, yeah. So what we do, like, I think what I'm going to do is basically build a recursive descent parser. I think that's probably the easiest. Also, like, I'm not going to... yeah, I'm not worried about, like, theoretical guarantees as well for this. So what we need is we need... we probably want something else that's like parse var and itself, because we need the rules. And then we need to know, like, what token... Like, we need to know what tocs are, what tokens we're going to parse. But we also need to know which variable it is we're parsing, right? Because the parsing code for parsing, say, a field will be different to the code. Like, the stuff we have to do in order to parse a field or a string will be different to a JSON value, for example. And this part is a tree. And then to do the parsing, we simply, well, we simply parse var. What is it? Well, it's self.start var is the first one we have, and then tokens are the same. Notice this is happy that this is not. In fact, tree is not quite this, right? We need to have the error case as well, which is like, oh, this might not be a thing, and because we are not. Because we're not parsing strings directly, then this is going to have a vec of tokes as its thing. This is now enum, or its node with these things. Let's like derive, clone, debug, all those good things. Right, now we're back. Like we have to parse probably. Should we represent rules? Yeah, maybe like it would be more performant to represent rules as a hash table rather than a vec, but for the time being, you know, we're going to do this. So what we need to do, well, we need to look at basically what we're going to do in order to parse, like the way you would write a recursive descent parser. Actually, this is not quite the same way you would write it. This is slightly worse than recursive descent parsing. But nonetheless, we would know which variable we're doing. But the thing is, so let's say we're parsing this string, right? We've got this, and as a string of tokens, and all we know is that it's a value, right? So we're basically saying, oh well, value to what is the question ultimately. So we're saying, hey, well, we don't know what value it is, but we do know what the string is. So we basically need to, one way of doing this is to attempt to parse every possible variant, because value has lots of different rules. Up here we have the rules. In fact, we can split and then open the same file twice. This is one of like the, also as an aside, this is like, I think one of the massively underrated features of Vim is that you can open the same file twice in two separate buffers. Sorry, the same buffer twice in two separate windows. That's just really nice. So this is our thing, and we've got how many is this? 7. Can I count? No, I can't count. This is 6. We have 6 rules to choose from for value, and we don't know which of them to expand. So we just attempt to parse all of them, which is like not a very efficient way of doing it, but it is guaranteed to be correct as well. And also, if you think about like the way these are defined, you could have like this is actually okay as far as a LR parsing is concerned. Like, oh, is it LR parsing? Yeah, when you parse from left to right and you only have one token of look ahead. So at this point, like I could know which rule I'm supposed to expand, knowing only the first token, right? Because I look at this first token, it's either true, false, null. It's a string, which like, you know, this would be its own token. We would take strings out in the tokenization phase. Or it's open, it's square bracket or it's curly brace. And then these would tell us which rule we need to follow. But in general, we can't do that because we might have something like what's the simplest example of an ambiguous grammar? I mean, yeah. So we simply expand the first rule that we come across that works. So in fact, what we ought to have is where even are we? We need to go to grammar.parse. What we kind of actually want is we want some kind of error, right? We might not actually be able to parse because we might somehow fail all of the possible rules. So, well, what do we do? Well, we look at for rule in yeah. So for every rule in self.rules, what do we do? Well, we look if. In fact, we should probably .iter .filter and x left hand side needs to be equal to var Okay, let's just always make this fail to start with. Hold on, is this? No, wait. We don't want to do this. If we do this, then we simply we return. If we get all the way through and we can't parse it, then we return error, and well, oh, where's error defined? Oh wait, it's defined underneath this, isn't it? Tree.error. Actually, yeah. So this is actually not enough. We need to know the variable. Like, we need to know what type this is, I think. So we do this and we return the type that we were given, and we return the tokens that we were supposed to parse. Oh yeah, well, it's a copied. Correct. I should do it. Okay, so pretty much like if we can't parse, so we try every possible rule, and if we can't parse the rule, like if none of the rules work, then there is an error. So we just like create an error node in its place. Parse. Oh, it's complaining that parsers never run. So we would put early returns in here, I think. It's just horrendously unperformant, by the way. I'm quite aware of this. So JSON grammar dot parse tokens. And this should return us a tree, except it won't, because it will just yeah, there we go. So it'll return an error to say that, oh yeah, well, all of these tokens were the error, and we can't figure out what it is. We knew it was a value, but we can't figure out what the things are. In fact, hold on. I think I've just had an idea, right, for how to like intuit the for how to derive what the keyboard shortcuts are supposed to do to this grammar, right? Because if keys represent transformations, then when you insert, like, say, IT into, say, an object, into an array, right? We know that then keys, like the character names, rather than corresponding to concrete things, they correspond to expansion rules, right? So does that make any sense? Am I just like going mad? I might be. I could full well be mad. I'm quite aware of that possibility. Actually, I need a drink anyway. I have like the world's most glorious headache because I stayed up till 3 AM this morning coding, of all things. And like, I don't know what a hangover feels like because I don't drink and therefore have never been properly hungover. But I think I feel like the cause of a hangover is dehydration and lack of sleep. And I think I went to bed very late, so I got the lack of sleep bit. And then I think I didn't drink very much that evening, like water. So I think I got both of the things that cause a hangover. So I think, like, definitely I ended up with what I think is a hangover. Right, I'm going to grab myself a drink. If you have any questions, stick them in chat, or if you have any light to shed on my sanity, then you can also stick it in chat. I'm back. Right, what were we doing? Okay, so we were trying to actually parse something, weren't we? Right. Oh yeah, so for each rule, we need to figure out whether or not to parse it. And in fact, I think I'm just going to... Yeah, I'm going to explicitly say this. So if the rule got left-hand side is not var, then continue. Right, like, obviously this is a horrendously inefficient way of doing it because, like, this continue is going to be hit a lot, like, when you're parsing. Like, you could optimize this away by, like, saying, like, turning self.rules from a vector into, like, a hash table of the vars. So that then, like, you actually know which rules you're going to have to sanely check. Like, you do even better, you could do, like, it could be a hash table of what the rule left-hand sides are, and also what the first token is going to be, right? Like, you could do that as well. And then we could even more efficiently just, like, figure out which rules are going to be possible. Right, so now we try them. And then we try parsing the rule, right? So let's, like, make another thing that's like parse rule. In fact, we could put this in rule, right? We could say fun parse, and then we take self, even though, oh yeah, rules are not declinable. And we know we don't need to pass the left-hand side of the rule anymore, right? Because basically what we've done is we're like, hey, we've got value, and we've got true, and like we know we're trying to parse this rule, so we don't even need to know we don't even need to parse the left-hand side because we know what it is. So all we need to do is the tokens, right? And then this might return something, like it either returns option tree or not. And so it might parse correctly into a syntax tree node, but it might not. You know, I'm going to backtrack and put this back in here. It's a dot filter. Is var. Yeah, so we filter out the ones that aren't. No, we filter for the ones that are equal. Okay, get it right. And then we rule.parse the tokens. And then dot. So this is an option, and then if it is sum, then we return, otherwise we keep going. So it's kind of like, this is kind of like the opposite of the question mark, I guess. But like if let sum t is this, then return return node. Stonks. Okay. Well, so basically the point is that if the rule fails, then we try the next one, and then if that one fails, then we try the next one, and so on. So we try every possible way of expanding the node that we have, given the tokens that we've got. And if they all fail, then we have an error, is basically the upshot. And also this has a really nice side effect as well, for the two people who are actually watching. Which is that this is automatically unambiguous, because it will take the first rule that comes along, and therefore it won't, hold on, let's give an example. So let's say, in like the whole like models of computation stuff, a grammar is unambiguous. A grammar is ambiguous if there are two ways of parsing the same tree. And like the obvious one is like expression is expands to either let's say it either expands to x, or it expands to expression plus expression. And then we can ask like, oh yeah, well what is x plus x plus x? Like how would we parse this? Because what we're interested in is basically like the tree of expansions that you end up with is the syntax tree of the program, right? As far as Sapling is concerned. So what we need to know is basically like what order do you expand things? And there are kind of two, right? Because you could, and this kind of corresponds to the number of ways you could bracket this. Because you could say, you could start off with expression. And then you could expand once into expression plus expression. Right? And then you could expand the left-hand side to say like expression plus expression plus expression. And then turn everything into x. So we've got like x plus x plus x. Like imagining that the brackets are just like how our syntax tree is grouped. Or we could do this another way, right? We could expand first, and then we could expand the right-hand side next. And this goes to x plus x. No, sorry, it doesn't. It goes to x plus, right? So now we've got two ways of doing it. And then the issue is that according to our grammar, like if this is just the only rule, then these two ways are both valid. And the grammar doesn't entirely specify what output we should end up with, which is like theoretically not very nice. And it gets even worse because we could do something like expression times expression as another thing, right? And like this gets even worse because we could have x times x plus x. And right, well let's go back to here, and we've got x times x plus x, and this is a time when you could expand both ways. Again, you could have expression, and then expression goes to expression. You could either expand like the times first, and then in fact let's start with expanding the plus. So we do expression plus expression. And we take this again and we expand the left, right, into expression times expression plus expression, and then we turn them all into x's. So we end up with x times x plus x. And obviously this is the one we want. Like anyone who's done primary school maths, like has it beaten into them that multiplication takes precedence over addition. So we want this one, but the issue is that this is not the only one. Like there's also we could have just expanded the star first. So like x star, we could expand this into expression times expression. And according to our grammar, this is perfectly acceptable. And then, well, this turns into expression plus expression. Well, yeah, so it turns into, we expand the right-hand one again because we need to get x plus x. And then we end up with x times x plus x. And this is like kind of horrible because we got two, like in the case of addition, then it wasn't too bad because it doesn't matter which order you add things. The result is the same. But this, like these two expressions have clearly different meanings and the grammar can't disambiguate. But the great thing with, the greatest and worst thing really about recursive descent parsers over some kind of system like this is that they're completely unambiguous. They'll only make one choice, and that's the first rule they come across. And we can use this to our advantage because the rules we actually want here are like, we want to expand, when parsing, we actually want these to be the other way around, right? We want to, if we see expression times expression, then we always want to we always want to consume the star before moving on to a plus. So if we can consume this type of expression, then we do it before moving on to here. And so that, like, with our parser, with our grammar specification, then this is completely unambiguous, and we don't have to do all of the, like, there's a whole load of janky stuff you can do to get a context-free version of like this expression parser, but it's just like completely overkill. In fact, I think what's his name, Matt K-Lad, who did he wrote Rust Analyzer basically. K-Lad ungrammar, and I think ungrammar is oh yeah, here we go. So this, yeah, this is exactly it. And like this is basically what we're saying, which is that, like, you don't. Okay, well, I'll leave it to, like, people who want to look at it. But basically, like, you have a set of rules, like we've done, and you just, like, you turn this into a recursive descent parser, and you always parse the first rule that comes along. So you just remove all of the ambiguity. And theoretical computer scientists hate you, but it actually works in practice really nicely, apparently. So I'm prepared to accept that that's a good idea, and that it will work nicely for Sapling as well. So, well, what do we do in order to parse this? Well, we basically have to check that tokens conforms to our right-hand side. That's basically what we've got to do, right? Because yeah, I mean, that's what parsing is at this stage. We've got this rule, and we need to know whether or not the tokens satisfy it. And if they do, then we return the tree that we got. So in our, do we have a hypothetical case? Where was the thing I was demonstrating? Oh, it was here. Okay, so I don't even know why this comment is here, but let's get it. So basically what we've done is we're like, our whole thing goes, we're parsing this, right? So we get to, we call JSON-grammar.parse, right? And then we provide our tokens. And, well, what does this do? Well, it tries to parse our root variable, right? So it's like, we've basically got this, and we know it's supposed to be a value. And then the thing is, we start doing this, and we don't know what rule to use. So we're like, hey, well, value goes to what? So we start trying everything. We're like, does this entire string, like we start, we go through every rule, and the first one is ain't true, right? So we say, does this, like, does this whole thing, is this true? Or like, does the rule for this to true? So first of all, we ask, is valid for this whole thing here? And the answer is no. Like, obviously, this whole string is not true. This is an array, but we don't need to know that. Like, we can't figure that out beforehand. We're just like, hey, is this true? The answer is no. The is value false for this, which I think is the next rule? No. Duh. Is this a null valid for this? No again, right? So this is an array. And we're like, actually, this stands a chance, right? Because the first token is an open bracket, and the last token is a closed bracket. So now we've got to split the stuff in here up and attempt to parse this. Oh, how do we handle this? Because, like, once we got this to an array, like, we need to say, does this conform? Like, we need to expand the whole, like, recursive calls thing as well. So, yeah, we do this, so we use rule.parse. And now we need to determine whether or not tokes uses it. Because, right, so the issue I see is that we can't, like, given this situation, like, how do we determine whether or not this is valid? Like, obviously these things on the end, right, are matched. So obviously we could say, oh yeah, well, these are the things. But we now need to check, what does our grammar actually, like, what does the specification say for what should happen as well? So this is an array, right? It starts with a token thing. Yes, that's obviously satisfied. And, well, now we repeat values and things, right? And commas. So that's a little bit nasty, because also we don't know how much of this is going to be consumed by each thing. I think we need to modify what we're going to do. So I think parsing a rule, it needs to not only parse the tree, it needs to also say how many of the tokens it's consumed as well. Because what we basically want to do is we want to iterate over for kind of like well, yeah, so the rule right-hand side is in self.right-hand side. Let's call them RSS rules. Well, we need to try and like match off the tokens in here, which is like even more recursion, right? Because we could say we could attempt to parse this. Oh wait, yeah, okay. So we need to know yeah, we need a counter. We need to let mu like how far through the tokens array are we? Tox consumed equals 0. And then like, what do we need to do? Oh shit, I've been streaming for 2.5 hours. That's kind of crazy. Wow, what a long time. So this is just a rule, right? And then we need to match on the rule type. Because if it's a RSS rule, missing match on, well, okay, yeah, but rule right-hand side. Alright, so first of all, if it's a token, and it's some token, then we need to assert that we first of all check is the tokens, like, is the next token to be consumed, if the next token to be consumed is the one we were expecting, right? So in this case we were trying to parse an array and it said we wanted an open bracket, then okay, that's fine, we've got an open bracket. Well, if we do that, then tokes consumed plus equals 1, right? Because we consume the bracket. Else return none. Because if we can't handle this, if we didn't get what we expect, then we just immediately reject. Is it happy now? No, it's not. Okay, does this compile? No. Okay, so we kind of need to, we need some more efficient way of saying, like, how much of the thing has been parsed, don't we? Because we don't immediately know how to split up arrays, for example, but we do want to know whether the entire array is valid. Oh, this is a bit gnarly. Let's, for the time being, just return 0, like the tree from it. Oh, yeah, I should have borrowed. Okay, so we ran our code and it panicked, which is fair enough because it would probably consume oh yeah, we should probably put some println trying and then self.c, I think. And so we should see that it tries true, false, null, and then eventually settles on array. And it's like, okay, well, yeah, so we could say, like, for rule, then we could say, oh yeah, trying to consume this rule, and we can see that it will try and do this, but it will either accept it or it will say yeah, and so we like unexpected token what was the token we were expecting? RSS rule, right? Oh no, it's the tox consumed that we want. We don't want to debug print this. Yeah, so we're like, it basically tries true, it is expecting the token true, and it gets open bracket, which is a failure, right? So then it goes, oh, I can't do true. This thing is not a true. Well, is it an open bracket? Well, so is it a false? Well, it's not for the same reason. Is it null? It's not for the same reason. And then it tries to consume the open bracket off the left, which is an open bracket. So it correctly consumes. So what we're more accurately trying to do is we're trying to match this. So we're consuming token thing and tokes tokes consumed. And yeah, so we should see that it consumes the open thing, and then it tries to match the parse the repeat, and we have no idea what to do anymore. Which is fair enough. I'm quite tired. I think I need to stop streaming soon, which is a shame because like nothing concrete has been done yet. But also I need to I'm going to need to look at the compiler that we were working on in over Christmas, like a couple of Christmases ago. We had a to do with the degree, we had like we got set an assignment to work on a compiler, and so I think I should probably look at that, because I think that the parser in that compiler did a similar thing to this. Because the thing is, I'm not sure, like, we need to parse, we need to have this parsing thing, like, they all need to consume, they all need to say how much of the input string they covered. Because we need to know, we need to start parsing this, because basically we need to say, so we go say, yeah, we'll say, we'll immediately reject this array as we know it's not true, false, or null. And then we get to array and we're like, huh, is this an array? And we think it might be because we've consumed this. And then we need to say is, so now the question now becomes, is, come on, is this, well, yeah, so we're basically saying, like, is this a value? And then in order to figure out whether or not this is a value, we need to try all of the different expansions for value. And so what this boils down to is we know that this is fine. And then we need to consume as much of this as we can and then find a comma. And then we need to know what... Yeah, so basically we're asking, well, is this thing without the opening bracket value? And, like, of course this isn't, because it has a load of things in it, but the first section here is. So perhaps a better question of, like, how much of this is a value? Because what we want is we want it to do is value to blah, blah, blah. Like, we need to test this for all of the possible expansions, and we can't. So we're like, well, does this to array work? Is it valid for this crazy string? And like, of course it is, because we know, like, it is valid for the subset of this. So we need to consume out, yeah, we consume the first bit again, right? We go $y is, oh, I wanted $y, not $y%. Is this a value? And we're like, is true, comma, thing a value? And then obviously, like, it is, because this is true. So we're like, is value true, valid for this thing? And the answer is true, but we only consume off the front. So we need to say yes, but we only consume the true off the front here. We only consume true. And now we return back out and say like, oh yeah, well now we've got this left, right? We've consumed true, so we've got this, and then we're saying like is value, and then we want expect comma from the remaining stuff, right? Which is all of this, and of course that's true. So we're like is value to true valid for false, and then like this thing. So we need to say, once we correctly parse something at any level, we need to say how much of the stuff we parsed, so that we can leave the rest for, like we can leave the rest to be parsed into the parent, like further up the parse tree. Not sure if this is making sense. I think it is. It's just that like I've been streaming for 2 hours, nearly 3 hours, and I'm like pretty dead. Yeah, let's just at least finish. Valid for this because we've taken the thing out. And of course the answer is yes. But basically because we've because we're using we've put all of the tokens into a slice, and because we've done that, we have unlimited look ahead, which all of the like theoretical people don't like, but I think it's fine. Because we can never like, I can't really see a way of abusing this. Okay, so how would we do this? Well, we need to it's a tree or a U size. In fact, yeah, I think we do need to, we return tree and a U size of how many things we've consumed. Oh yeah, this is really not very error resistant, because if we get to a point where all of the rules fails, like we have, I don't know, like X here, then it doesn't know to fail. Like obviously we'd want X to fail, but for the parsing to carry on. I need to think about this, and thinking is not high on my priorities list right now. Whoops. So I think I'm going to call stream there. It's probably about time I stopped. So yes, it was nice streaming. It was fun as well, right? Like it was long, and I'm a bit hungover feeling, but so be it. Anyway, I will see you all next week, hopefully. Oh, and I think that this streaming setup, like streaming from my PC with my phone as like the looking at chat is a good setup, I think. But anyway, I think that's enough. That's more than enough for today. So I will see you guys next week. Bye.